let's take a look at the think about it. Shelly read her book for 1/3 hour each afternoon for 8 days. How many hours did Shelly spend reading in all 8 days? So what information from this question is important for us to know? We need to know that she read 1/3 hour each afternoon and that she did that for 8 days. What's another important key word in this question? In all. What does in all tell us that we are going to do? Say it out loud. Right, we're going to add. So one way that we can represent this is by making sure that we're taking into consideration all 8 days. So 1, 2, 3, 4, 5, 6, 7, 8. We know for each day she read for 1/3 hour. And we know that we have to add it together because it says it all. So when we're adding fractions and the denominators are all the same, it's important to remember that we can add them because the denominators are the same, but we are not changing the denominator. So the denominator is going to stay thirds. How many thirds do we have? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. So here we would write 8/3. So when we take a look, we end up with 8/3, but that doesn't really tell us how many hours. So we have to think of another way that we can look at this question. What's another way that we can look at this question using the information that we have? Say it out loud. All right, so one thing we can do is we know that we need 3/3 to make one whole. So we can actually group these into wholes. So let's do that now. 1/3, 1/3, 1/3. This makes one whole, or 1 hour, 1 whole hour, because we have 3/3. We have another set here, which makes another whole hour, or 3/3 of an hour, which would be 1. Then here, we do not have 3, we only have 2/3 left. So if we're going to look at this as hours, we could say 1 hour plus 1 hour plus 2/3 of an hour would be equal to how many hours? Right, 2 whole hours and then 2/3 of an hour. 2 and 2/3 is called a mixed number. The reason this is called a mixed number is because it has a whole number and a fraction. So anytime we're working with a mixed number, we're working with a whole number and a fraction. Now we had 8/3, which is still correct. And we had 2 and 2/3 when we broke it down a little differently and grouped together to make wholes. So 8/3 is the same thing as saying 2 and 2/3. So our key point today is that fractions greater than 1 and mixed numbers can represent equivalent fractions. When we say fractions greater than 1, how do we know that this fraction is greater than 1? Right, the numerator is greater than the denominator. So once the numerator is greater than the denominator, the fraction is greater than 1. And remember that this is a mixed number because it's a whole number and a fraction together. And these are equal because we have 2 groups of wholes and 2/3 left over. But if we were to just look at it as the unit fractions of 1/3 and add them together and left it as a fraction, we would have 8/3. This is a fraction greater than 1. This is a mixed number, and they are equal to one another. As we're going through, I would like for you to remember this key point if you'd like to jot it down to be helpful, it will be on the next slide. So take note of this so that you can apply it to the rest of the lesson. You're going to do great. Keep it up.